Okay, so compound interest. Interest is money paid for the use of money. If you open savings account at the bank will pay you interest for as long as the account is open. If you borrow money from the bank will charge you interest for the privilege of using their money. So we are going to do some questions on the compound interest and half life, and basically exponential functions are going to be used here. So suppose you have $100 to invest and know the several investment options, each offering 5% interest. The Bank of Montreal offers 5% interest compounded yearly. The compounded means that the bank looks at your new balance at the end of each period and calculates interest based on that. So the interest is 5%, and 5% means 5 by 100, which is equal to 0.05. So, and the amount in the 0 years was $100. So next time the amount would be 100 times the compound is the bank Montreal offers 5% interest means it's a bank interest compounded yearly. So because it is for 1 year, so we're going to multiply this with 0.05 with 1. We're going to add 1. So 1 plus 0.05, which is equal to 1.05. So now 100 times 1.05, which will be equal to 105.00 dollars. Now 105 multiply by 1.05, which will give us 110.25 dollars. Then it's going to be 110.25 multiplied by 1.05, which will give us 115.76. Then 115.76 times 1.05, so it will give us dollar 121.55. Okay, the next question is the Bank of Saskatchewan offers 5% interest compounded quarterly or 4 times per year. This means that the 5% is divided into 4 parts over the year. So the bank pays 1.25% on the principal every quarter. So it's going to be 5%. So 5% can be written as, okay, 1.25% can be written as 0.0125, and added per year would be 1, so it would be 1.0125. So it would be 100. Here it would be 100 times 1.0125, which will be equal to $101.25. So 101.25 times 1.0125, which is equal to $102.52. 102.52 times 1.0125, which is equal to $103.80. 103.80 times 1.0125, $105.10. Okay, the Bank of Nova Scotia offers 5% interest compounded monthly 12 times per year. How much saving will you have after 1 year and after 4 years? So again, the same formula that we used last time, that was A of t is equal to P1 plus R to the power t. So A of t here is after 1 year, A of 1 is equal to 100. 1 plus what is R? 0.05 compounded monthly 12 times, so it's divided by 12, and here it is 12. Solving this, we will get 105.12. And for 4 years, a of 4, which is equal to 100, 1 plus 0.05 divided by 12, 12, and here we're going to multiply by 4. So here it is 12 times per years, but it is for 4 years, so 12 multiplied by 4. Okay, so dollar 122.09. The Bank of British Columbia offer 5% interest compounded daily. How much saving will you have after 4 years? So after 4 years, it would be a of 4, which is equal to 100, 1 plus 0.05 divided by, okay, so it could be Bank of British Columbia offer 5% interest compounded daily. So we are going to take 1 year, and it would be 365 days in 1 year. So it would be 365, and for how many years? 4 years. So multiply by 4. So when we're going to solve this, we will get the answer $122.14. Okay, so compound interest is the interest earned on the original principal and all interest earned previously. In other words, at the end of each year, the interest earned is added to the original amount and the new sum of the money is reinvested. A of t is equal to P of 1 plus R over N NT. P is the initial investment, R is the annual interest rate, N is the number of compounded periods in a year, T is the time in years. So how much you deposit in an account that pays 6.25% interest compounded semi-annually to have a balance of $5,000 in 15 years. So this is the next question. So what is the information given? Okay, so how much would you deposit? Okay, first of all, let's write the formula. A of t, which is equal to P 1 plus R to the power t. So how much would you deposit in an account that pays 6.25% interest, which is equal to 0.0625? So have a balance of 5,000. So balance is P. How much to deposit? Initial amount we don't know. 1 plus 0.0625 divided by semi-annually, and get 2 times per years. So T is going to be 15 years multiplied by 2. So this is simple calculations. It's going to be 0.0625 divided by 2 plus 1 to the power 30. It's going to be 2.517. Okay, so 5,000 divided by this is going to give us 1986. So P is equal to 1986.33 dollars. Okay, you have $2850 in an account that pays 4.12% interest compounded monthly. So now they're going to compound monthly. So if they're going to compound monthly, the value of the investment after 8 years. So A of 8, which is equal to 28501 plus 0.0412 divided by 12 months and 8 years, so 8 into 12. To solving this, we will get $3960. The time it takes to double the value of your initial investment. So double means 2 times is equal to 1 plus 0.0412 divided by 12, 12 into t. So what is happening here? The time it takes to double the value of your initial investment. So the initial investment, we need to double it. So we need to find the time that would be taken. But 12 is that it is compounded monthly. So we have it in 12. But the other time we're going to find it like this. So solving this is 2 is equal to 1.00343 12t. Okay, let me take log on both sides, which is give us log 2 is equal to 12t log 1.00343. Log 2 divided by log 2 divided by log 1.00343, which will give us divided by 12, which is give us 16.853 years. So t is equal to 16.853 years. If compounding were quarterly, now it's going to go quarterly, what interest rate would you need in order to produce the same value after 10 years as compounded monthly? So a of 10 is equal to 28501 plus 0.0412 divided by 12, 12 into 10. And we get the result $4299.99. Okay, the next is, now we need, if compounded were quarterly, now we need 4299.99, which is equal to 28501 plus r over 4, because now we're going to go for compounded quarterly. So it's going to 4 into 10 years, because it was 10 years. So dividing this, we will get 1.50877, which is equal to 1 plus r over 4, and here it is 40. So it's going to be taking log on both sides, then 40 is going to come in the initial, it's going to be 0.178623 is equal to 40 log 1 plus r by 4. 40 will be divided over here. Now writing it in the power of e, it cancels log. So solving this, we will get r is equal to 4.134%. Okay, so radioactive decay and half-life. Half-life is the amount of time it takes for half of the radioactive atoms in a sample to decay or stabilize. Different atoms decay at different rates and thus have different half-life. Scientists use the half-life of carbon-14 to date according to the times. Okay, when an organic substance dies, the carbon-14 atoms begin to decay. If there were initially 100 grams of carbon-14 present in a sample, calculate how much carbon-14 remains after several half-lives. So after the first half-life, it will remain 50. After second half-life, 25. Third half-life, 12.5, and third 6.25. Sketch the graph to model to show how the amount of carbon-14 present in a sample changes with the number of the half-lives. Stop and think, will there ever be a time when no carbon-14 atom remains in the sample? So what is happening here is number of half-lives are 1, 2, 3, 4, 5. And here it is 25, 50, 75, 100. So when it was 4, it was 6.25. So it was here, then it was increasing. Okay. Okay. So the next one is, if x is the number of half-lives, write an equation to model how the carbon 14 changes. So a of x would be equal to 100 1 by 2 x, because we're dividing it with 2 every time. In 1947, earthenware jar containing what are now known as Dead Sea Scrolls were found in Israel. Analysis showed that the scroll wrappings contained 78% of carbon 14. How many half-life had passed by the time of the scroll were discovered? So 78 is equal to 100 1 by 2 to the power x, and x is going to equal to 0.358 half-lives. If the half-life of carbon 14 is 5730 years, how old were the scrolls? In what year were they created? So T is equal to 5730 multiplied by 0.358 is equal to 2051 years. So in 1947 minus 2051 is equal to minus 104. So it's going to be 104 BC. A quick Google search tells us that the Dead Sea Scrolls were written between 150 BC and 70 AD. What is it about these scrolls that enable scientists to use carbon dating to determine their age? The scroll wrappings were made from the linen, which come from the fibers of a plant. Okay, another way to represent the half-life of carbon 14 is using the equation A of T is equal to 101 by 2 T over 5730, where T is the number of years the substance has been decaying, 5730, and half-life of carbon 14. Otherwise, how this model works by filling this table below. Okay, so for 0 years it's 100. So because it's 1 by 2, so just divide it by 2, very simple. 50, 25, 12.5, 6.25. How does this model compare to the one in the part C? Input years, not half-life. In what circumstances would this model be useful if you want to solve for the half-life? If a sample carbon 14 had changed from 15 gram to 6.054 gram, how long had it been decaying? Okay. So exponential decay of a radioactive substance that can be modeled using the formula A of T is equal to P 1 by 2 T over H. P is the initial amount as usual. T is the time of the substance has been decaying for, and H is the half-life. So problem set, $1,000 invested in an account that pays 4.5% compounded or quarterly. What will be the balance after 10 years? So very easy, we're just going to follow the same formula. A of 10, which is equal to 1000 principal amount, 1 plus 0.045 divided by 4, and what will be the balance after 10 years. So it would be 4 multiplied by 10. Why 4? 1,000 invested in an account, it has 4.5% compounded quarterly. So this is quarterly, so therefore it is 4. So R is 0.045 divided by 4, and here it is 4 times 10. So just solving this, we will get $1564. How much money must you initially deposit at a rate of 5% to have 15,000 is equal to P1 plus 0.05 divided by interest compounded quarterly again, so divided by 4 into 20, because 20 years. So by solving it, dividing it, we will get P is equal to $5552.50. Okay, Courtney want to have $5,000 in an account after 12 years that earns 7% interest compounded monthly. So now it's compounded monthly. So it's 5,000, which is equal to P1 plus 0.07 divided by 12, and compounded monthly for 12 years. So it's 12 into 12. So solving this, because this is very easy to solve, just simple multiplication and division, so I'm not solving it. to 163.83. Okay, the radioisotope radon 222 has a half-life of 3.8 days. Okay, so it's A of how much of a 10-gram sample of radium 222 would be left after 15.2 days. 15.2, which is equal to 10, so it's going to be 1 by 2 T over 3.8. So let's solve this. What is T over here? 15.2 days. So it's going to be 15.2 divided by 3.8. Okay, so it would be 0.625 grams. Iodine 131 has a half-life of 8 days. A of, if the amount of iodine 131 in the sample of 8 gram is 35 days. Because this is very easy, we need to put everything in the formula. What is 8? 8 is the days. 1 by 2 is in the formula. 35 by 8, because after 35 days in total was 8. So we are going to divide them, and we will simply get the answer 0.386 grams. Sodium 24 has a half-life of 15 hours. So it's going to be, if a sample of sodium has changed from 18 gram to 1.1125 gram, how long is that been taken? So it's going to find the time T. So here it is a bit difficulty. A of T is equal to 18, 1 by 2, T by 15 hours. So 1.125, which is equal to 18, 1 by 2, T over 15. So dividing this, and in this question you need to take logarithm. So divide 1.2125 divided by 80. Let's do this. Okay, 1.125 divided by 18 is 0.0625. Log is equal to log 1 by 2 T over 15. So log 0.0625 minus 1.2041, which is equal to T over 1.5, and log 1 by 2 is minus 0.301. So now it's easy, just divide it and multiply it, and you will get the answer of T, which is equal to 60 hours. After 42 days, a 2-gram sample of phosphorus 32 contains only 0.261 gram of the isotope. What is the half-life of phosphorus 32? So it's 0.261, which is equal to 2 1 by 2, 42 by h. What is the half-life of? Okay. So divide it, take logarithm, and you will get h is equal to 14.296. So we are done with it. Thank you.